Welcome, 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 welcome. My name's Blades, and I'm going to make this the February bonus video. If I start ranting halfway through this video, don't worry about it. It is about programming, a matter that is very close to my heart. It's about bad programming. And yes, we have some. Some absolute idiot of a programmer has gone and done this in our game. If you go back to the game 3D game programming series and you'll have a look at episode 10, Windows Errata. Something happens. Oh, nobody spotted it yet. That's okay. Something happens here that is, well, bordering on the ridiculous. What happens is, some idiot of a programmer comes along, comes into game, gets to moving the snake, and writes a few lines. A few lines that are disaster. Absolute disaster. Growing snake, or grow snake, as it's named here. If anybody presented me with that piece of programming, I would ask them if they were still on this planet or were actually a programmer, because it's not wrong. It does what it's intended to do. But why? That's the question. The question is, why does it do what it's intended to do? Let's read it. So we get the number of segments of our snake, which at the start is 0. We only have the head. The head is segment 0. Now, if the segment is greater than 0, then everything seems fine. We just grow and that's it. Alter the move speed and move on. End of story. But there's an else. Why? If the segment is not greater than 0, then it must be 0. In other words, the first segment that we are ever going to add to our snake is treated differently. And it's treated differently in such a way that I can only say, oh my God, what's that? Yes, we give it a position. It's the only segment that we give a specific position. Why do we do that? Well, let's find out, shall we? Now, we do this because it won't work, is a simple answer. And this piece of programming makes it work. He says, taking it out very carefully and making red squiggly lines everywhere. Now what I've got here is exactly what the grow snake function should look like. So I can now take my programming off. This is now good programming, because it doesn't carry what I would call bug-prone code. Or no, actually what the industry would call bug-prone code. I call it bad programming. It's got an else which treats the first segment as a special case. And it's treating that special case in such a way that is ridiculous. It's made up. It's plucked out of the air. It's not calculated. It's just fake magic number settings, which mean absolutely nothing. Yeah. Let's run build. I know what's going to happen, don't worry. It's not going to work. And there we go, got our correction. Let's just run that. There we go. It stops as soon as it gets to trying to grow the snake on the first time. Why is that? Remember, I made the specification during the series, as I was programming it, that to move the snake and to do the collision test had to be done after we move the snake. Is that what we did? In a way, yeah. So that shouldn't be the problem, should it? We move the snake and then we check for a collision, and if things collide we stop the program, just like we did there. As you can see, I could press return, enter out of, and by pressing enter you're going out of the program and it all closes down and everything's hunky-dory. The output is fine. Debug console, fine. Now with good programming, this program doesn't work. How interesting. And that's the point. Some idiot of a brain ache came along to a very, very good program that didn't work and fixed it by putting an if-else statement in. To me, that was hacking. Very, very hacky. It's just fixing it's like your window pane keeps just falling out of the window frame. So your window keeps falling out of its window frame. How do you fix it? You go up to it and you nail the window to the frame. Now you know damn well later on that's a bad idea. This is the same thing. If you don't shatter the window in the process of doing this, you're just lucky. That's a bug. You will see this in programs. You will see this on the internet. Programmers doing this. Right, let's get rid of it. That's a bug. This is what this function should be. Okay? Where you've got segments, you can replace msnake getNum segments. And we only have segments in once. So really, you don't need this int. That's redundant. I'll come back to that. I'm actually going to leave that in because that redundancy actually makes sense to do for the readability of that line. Because what we're doing now is we're taking we are going to grow by another segment, and we're going to set its position to the current segment, and that is exactly what we should be doing. So when you grow the snake, that's exactly what we should be doing. Nothing more, nothing less. That is redundant. I mean, you could put msnake getNum snakes in there and there. But hey ho, it's choice. Do you want to be able to read it or not? Now I'm saving that. Got a problem now. The program doesn't work. Now remember the original specification. This is now correct. Excellent. The original specification was that we should do the collision test after we do the movement. So let's see what we're doing in our game logic, shall we? Oh, look at this. In update game logic, what are we actually doing? We are checking for a collision after we've moved the snake. It's correct. No, it's not. What we are actually doing is we are checking for a collision every single time we go through the update game logic. If you go to update move snake and follow the logic through, let's go over that, just follow the logic through. Update, collision, here we go. What happens is update does the keyboard, and then at the bottom we put final movement in, because I wanted to keep keyboard and movement separately. So the final movement comes along and it counts down, and if the countdown is to 0 in practice, then we move the snake. So for the first countdown, M countdown, for the first 15 times we go past here and we never move the snake. Hold on a minute, follow your logic back. The first 15 times we go past move snake, we don't move it. So on the 15th time we go through update game logic, it's correct. The first 14 times it's incorrect. We haven't moved. We're doing a collision check. We haven't moved. If you do it that way, what happens? There you go. First 14 times it doesn't move and we're doing the collision check. That is exactly what is supposed to happen. That is the correct response to our code. Our code is obviously faulty in some way, and so is my debug adapter on Microsoft Visual Studio. Oh, Microsoft, get your programming right. There's nothing wrong with my debugging. I'm not even using it properly or asking for it. That's probably why you're giving me an error. Anyway, that's beside the point. Isn't this funny, hey? Some idiots come along and 14 times they've decided to do a collision check, and on the 15th time the piece of code is right. So 1 in 15 times at the beginning of the program before the countdown comes down, the code is correct. That is awesome. Who programmed this rubbish? Oh dear. Oh bless. Blades, blades, blades. What have you done? It was done on purpose. It's okay, don't you worry. This is not me holding my hand up and saying I've done something wrong. No, I did something on purpose to show so that I could do a video on bad programming. So what I did was I naively programmed something in a hackish way so that it would work. The program would work, there'd be no problems, blah-de-blah-de-blah, and everything would carry on. End of story, end of session, and now I'm sat here talking to you about it. Ignore me notes. That's just me reminding me of what I am doing. Now, I know that this is wrong, so why is it wrong though? Yeah, it's doing it 14 times, but it should really work. In theory. Where did it go wrong? Did it go wrong with the hack? Did it go wrong with the game logic being wrong? No, is the answer to both. It went wrong in the design stage. You see, I did something in the design stage which means that you have to program it this way. I made a design choice that nobody at the time would ever have realized that it would then create bad programming. So the bad programming is derived from a design choice. And let's save that out. We'll come back to you in a moment. No, I'll just leave. I've altered it. Yes, I can leave it up. Where was the design choice made? Here. The question is, and I didn't ask it at the time, and I didn't say anything. Well, actually, I did. I did say anything. I tried to cover my tracks. I said that I didn't want anybody to touch the final movement. So I made it private. Why didn't I want anybody to touch the final movement? The reason I didn't want anybody to touch the final movement is because I didn't want the game to work. I wanted the game to fail so that I would have to do an errata and put a piece of code in that I knew was wrong. It's a design choice. There's no reason why another part of the program can't call the final movement. Why is the final... You see, here's the problem with this. And the bit where your ears prick up and say, Blades, you're talking rubbish. This is where you should have said, what is going on? Because if you look back at the update move snake, yes, it does the keys. And my explanation for putting that line in at the bottom was I wanted to keep the movement separate from the keys. And yes, I do. I mean, I have no doubts about that. You should, because that then makes the keys mobile. So I could take that out into, I could replace this with an input routine, which I could then expand out into preferences routine, so that I could give the user options for which keys they wish to press on the keyboard for the actions that are taken on the screen. Yes, that's why I actually want to keep the keys separate. It has nothing to do with the final movement. The final movement is actually what I didn't want to happen, because the keyboard should be separate from your movement, because the keyboard has to be separate eventually in a larger program or in a game. And that's just the truth of the matter. It's not about design choices at that stage, but to do this and put it in private. Why did I put it in private? I didn't want anybody to touch it. There's nothing happening in there that couldn't be touched. But I specified that you cannot do the collision check until after you've moved. And the only time we actually move our snake or our snake head, which is the part that we are detecting in the collision, is there. Those 3 lines in all of the program, that is where we move the snake, and then we store it in the position of the player. So when should our collision be? collision detection goes here, doesn't it? It's the only place it can go, because that's the specifications. It can't go outside of this if statement, because nowhere outside of this if statement do we move the snake, ever. At all, ever. And that's why I designed it this way, because there's only one point in the whole thing, and it comes here, we actually move the snake. And my specification was collision after movement. But if you move it here, can't you put the collision outside? No, you can't. It's a design choice. But we can't access final movement to do a collision detection. You don't need to. There's your collision check. Yeah, collision check's here. It's actually part of snake. But how then do we, if you're not going to be calling, well, I suppose we could still do it final movement here and have this, the final movement, private. But it doesn't make sense. Why? What could somebody outside of this function, or by calling this function, what could they cock up? They could cock up when the final movement happens, because in game logic it actually matters. In game logic, currently, the final movement is part of this line here. So that includes your final movement, and then we did the collision check. So if I make this collision check part of that line, where it should be, at the moment, it should be inside of that line. Do we need control over this collision check? Yes, I think we do. It's, again, a design choice. It all comes down to a design choice. As we have this currently, this is in the wrong place. This collision check has to go inside of that line. There you go. The collision check should be part of move snake final move, which I've just explained. This should only happen after we actually move, not all the time. Because at the moment it's all the time. It should happen within that if statement, after the point of movement. mCollide should be equal to move snake final movement player position. Wrong. I've got that wrong. It should just be final movement. I can take that out. There you go. Final movement. To do this, update snake must be altered as well. Hold on a minute. I want to access final movement and it's private. Ooh. That was a design choice. So, what do you do as a programmer? You're working at a game company. You've spotted this. Do you go back to your manager and say, I want access to final movement, and tell the design team that there was no need for final movement to be private in the first place, or give me a damn good reason why it should be? Would you do that? Would you query that? Would you? No, you wouldn't. You just leave it all alone and think somebody's hacked that and stuff it, and you just carry on your work. What would happen in the future if game logic was expanded? Maybe you wanted the snake to be able to jump over obstacles. Maybe you wanted to put some of the goals that we've created on top of obstacles, up ladders, on different levels 3D vertically. Because remember, I've just made a horizontal 2D game into a 3D game. All I've done is a flat plane. So I haven't actually utilized to the extent of 3D. What happens if you put the camera inside the head looking forwards and the camera moves with the head? That's a whole new can of worms opening up there. Is it possible? Yeah, I could do it now in, 2 minutes? Because it's all set up for that change to be made. And that's because the design choice was flexible. I designed this in a fashion to be flexible. And then I went and did this weird thing. So let's have a proper design choice to start off with. The first thing is the final movement should not be private. There is no reason for it. Okay? And the final movement should include a collision check. And because of that, it needs to have a bool. So let's change that. Bool, final movement. Anyone can access it. Yay! What happens then? It makes some programmer somewhere jump for joy, because now they can write the sequence properly. And the sequence goes something like this. Collision check detection goes here. Collision check is just above us here. It's here. There you go. Copy. Hold on a minute, I've got a bool. Wait a minute. Bool. Collision equals, false, we'll call it. Okay, let's just make sure I've got a bool. Our cool bool. Hey! And of course at the end of here, you have to return your bool, which is collision. Okay. Now, he says not being able to spell right. Oh god, I'm getting worse. Sorry, it's not your fault, that's mine. We've got a collision. We can now do a collision check. How does that then work? Well, how's about typing in collision? It works in the obvious way. Equals collision check, which we have here. Open brackets, and what do we need to put in there? A position. What do we check the collision with every single time? The head. The head of the snake is the only thing that gets checked for collision. And by programming it this way, it makes sure that unless later on the tail can waggle about a bit and move on using some freaky kind of physics. If there's obstacles there, the tail might hit an obstacle, say, then you would need to check the tail for collisions as well. You would have to have a collision check for tails, and you would probably have to have that either inside the if statement if you wanted it only when things moved around, or you might put the waggling of the tail outside the collision, outside of this if statement, and therefore then the collision check could go outside of the statement. The collision check itself has to go with the movement. Those two live together, hand in hand, dovetailed forever. That collision check, by the way, doesn't now really need to be here. All of that can go in there. Why do we keep it as a separate function? Because collision detection systems are interchangeable, and you might want a different collision detection system. There are so many of them, you can write them so many ways that, wow. No, you keep it separate, trust me. Okay, we've got the collision detection right now. Okay, I'm happy. Final movement now works. And it's a proper function. It's properly set up. It's accessible. Move snake is now complete. Game logic is all over the shop. Game logic's, well, nearly up the spout here. What we now have, though, is that mCollide is equal not to move snake collision check, but to move snake final movement. And the final movement itself couples that collision check inside it at the correct placement and at the correct time. So we'll do that. I'll activate that. There we go. That's actually code now. So mCollide, dead. Got a dead there. mCollided equals move snake final movement. Well, we don't need this collision check anymore now, do we? Because it's now included all within there. Okay, let's get rid of it. Bye. This line is funny. Why is it here? The reason this line is here is because I knew that this was wrong, and I wanted to explicitly tell the compiler to compile our code in this fashion so that I could tell if the hack didn't work. I needed to know whether our hack was working properly. And now I know that we've got the proper function in, now we've got the proper collision checking going on. I don't need this anymore. It's redundant, completely redundant. That line does nothing. Absolutely nothing. So cut that. Pop it in here where it should have been in the first place. Paste. That's good. That's not needed. Now, have a look at the code now. Look at it very carefully. How it reads. We update the snake, or we update move snake, which is the actual function. Move snake is the class, and we update the class. That's how that should read. That should read, I'll do it here properly now. If I was putting notations in and I was doing doing it fully, every line would have some kind of description. So this would act, as you've seen me do it in the past, update move snake. And then this line would be complete the move no, complete snake movement at correct speed, which is what final movement actually does. The word final movement we can now change. We can now call it move. It isn't final movement, it's move. So, update snake, and then it's just move snake at correct speed. There you go. So now, back here, that changes to move. And move snake here changes to move. Okay. That now describes exactly what this does, and it does exactly what we are asking it to do. So we move the snake at the correct speed. That's it. Would actually add check for collision only after the snake moves, because that's still doing two things, which I don't like, but it's a function doing two things, not one. If you notice, I always try and write functions that do one thing, not two. It's good practice always to have your functions doing one thing. In this case, because they are so closely tied together, we can get away with a function that does really two things, not one. It really should be move snake and then mCollided equals check for collision. But we would have to pass a value out of move to state that the movement has occurred. So we would still need a bool, but the bool would be return move has occurred. And then it would be if move has occurred, check collision on the next line. Do you see what I'm trying to say? That's how you would split your check collision back out. It's not needed. That's now how the game logic reads. Update move snake, move the snake at correct speed, check for collision only after the snake moves. Okay. Are we happy? Joy joy? Do we think it'll work? No. I still got final movement in a function somewhere. Yes, I have. You're quite right. I didn't take it out. You see, that's what happens when you've got these loose ends. That's a loose end. Have you ever seen a line like me? Have you ever seen me type a line like that before? No. No. I never have a function call or a direct function call in a row. It's usually, if you're calling a function, it's because you need something. Functions should do something or give something back. Not all, but 90% of the time. Let's be honest. If you do see something like that in a program, query it straight away. Is that function needed? Is the first question you should be asking. Okay, we've compiled. And I've done it again because Microsoft is crap. Grr. I'll just save it out, I don't care. And now, when we go to play the game, check first. Doesn't work. We moved and we checked the collision and it's still wrong. Interesting, you may say. It's because we're spawning inside the head. Now, something that I haven't said is one of the definitions is that the head can obviously crash in with the snake, collision with snake. How does the head collide with the very, very first body item? It would have to turn around on the spot. Is that allowed? good question, Blades. Don't know. Let's just have a quick look through this game logic again. Dun, dun, dun. If we collide, movement snake, update snake, blah 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 blah, m collide equals move snake move. Looks better. Is it right? It's close to it now. Very close to it. Our problem is still being caused when the first segment drops. So while I is greater than 0, we drop a segment to I minus for the movement, and then we move the head. But we spawned it and the collision check still detected it. How? That's interesting. So the collision check happens before the spawning. Should do. Collided. Let's think through. There's our goal reached. It should move before goal reached. So it moves, checks for a goal reached. If the goal has reached, it will then spawn a snake on top of the last position of the last segment. Actually, on top of the segment. So it's going to spawn on top of the head at 0. It then goes round and it goes through. Hold on a minute. If goal reached is in the wrong place. If goal reached should only be after we move. The only time we move, same argument, is here. So we should be able to move, check the collision, and then check for goal. Hold on a minute, so what's the point in game logic? It's because this is in the wrong place. You shouldn't be moving the snake here. Although it's in move snake and it's the whole point of these functions. Because the game logic has to go in this little bit here. We can take it out, as I said. What we would do to do that is we would return a collision. No. We just have a return. So that becomes ret. Okay. That becomes nothing, no collision check. Let's take it out. That becomes, doesn't matter, ret equals true. So let's give this a proper name now, shall we, instead of ret. Let's call it moved. Yes. Moved equals false. Now it reads right. Moved equals true. Moved equals false. So we're not returning whether we collided or not now. We are returning whether we have moved or not. We are now passing everything back to the game logic to decide what happens. So we now know that we've moved. And it's a bull. Oh. I've added. Don't like doing that, but I'll think about that some other time. Moved equals move snake. So if move equals false, so that becomes check goal if moved and check goal reached. It doesn't really matter which way. Sorry, it does matter. It matters to my mind. That's all, because it's logic. So if you have moved, and oh gosh, and check goal reached is true, then there you go. We still haven't checked for a collision. Now, we can't check for the collision here at the bottom. Because if we do, and that is true, we have a collision this is the collision that we are trying to avoid happening. So instead, we'll check it there and just get it out of the way with, as I said, after you've moved, so that there gets cut. Now you know why it's better to have functions doing one thing rather than two. So I'm trying to explain as we go along why and how you create functions and what is good programming and what isn't. So now you can check if you collided. So it's m underscore collided, back to what it was. Equals check for collision. Check. And it's disappeared on me. It's mmove snake, isn't it? Collision check, I had it even wrong there. And it equals, are we on snake or player? Player. M underscore player. New position. You may notice. Yes, get player position. There it is. Forgetting how to program this. Come on, it's only been a week. They only did this a week ago. Now, is it right yet? No, it's not. Because remember, we are now doing this 1 in 15 times. We're back to the original error. Collision check. Yeah, that's right. Yeah. What that needs is if. And it's moved. We only want to be checking this after it's moved. There you go. So we'll pop that in. That is the original error that we had. And that is the line or the statement that we didn't do logically. We didn't say, has it moved? Now, if it's moved and the goal is reached, then will they both be true? So, let's see what happens. We move the snake. We then check for a collision. Yes or no. And it says no, because there isn't a collision at this stage. If we, because that's ends, that's going to be a game breaker, a game ender. We move, we hit a goal, and we have moved. We put it down in position. We put something down in place on top of the head. The next segment goes on top of the head. It comes through there. Will it move again? No. Move goes back to false. So it goes across here. It's still false, and it'll do this, God knows, X number of times until it moves again. And when it moves again, we change the position of the head. The segment goes into line, into the correct position, and there's no collision. So you move off the collision. That still returns false. So it should work. That move snake, okay. Which one? Bull move snake, blah 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 blah. Before the token, yeah, I didn't put it in, did I? Sorry. There. My bad. Bad typing. Okay. Let's try it. What do you think? Was the explanation of bad programming correct? What do you think? It is to me. We should never ever have split that. The design choice was wrong. That was the bad bit of the programming, and it caused a hack. Now we've taken that out, we've now had to do some good programming, and it didn't work when the program wasn't good. That's good design choice. So we now know we've got a good design choice. We now know we can expand this, and it doesn't matter how we expand the logic of the game. Because we've got everything now in the right order, the game will work, won't it? There you go. Crashed into the side. Just got to do one. No, I don't need to do the other test. I know it works. Yeah, I'd like to see if anybody comments on this, because this to me is how it should have looked in the first place. It should have had a moved value. It should have had a collided value, which we'll keep, because that is that really a member value? Really? That's another thing that you have to start questioning. I haven't gone through this and questioned everything, but we still have. Actually, we have a value that's not used now. We're no longer using, what was it? Goal reached, I think it is. Yeah, check goal reached is now a function, not a variable. That's no longer needed. You see what happens? It removes a variable as well, which means if I try and compile it now, it'll say this variable is not being used. So it is gamelogic.h. That isn't used, which brings me to question whether we need mcollided. It really does, because this is how you can check, and this is something you can do for yourself and decide for yourself. What you do is you go to your game, and if it's anything like this, it's got a right hand side bar here. On it, everything that has been changed is in blue. Okay? Now I think this is complete and finished, and I'm not going to make any more changes to it. So let me just get rid of all of my markers. I get rid of all of my markers by saying they're all saved, it's compiled, it's fine, and now bad programming corrected. I actually had to make I did a bad programming in it, so I could go backwards if I got it all completely cocked up for you. I didn't know that I was going to be able to do it like this straight away, because we're up to 55 minutes now. This is not a rant, this is actually true. because I did it. I know that I did it. So all of my markers should have gone, except for the ones that I'm on. Right, let me just get out of that. There we go. All of my markers on the right hand side have gone. M collided. Do we need this variable? Look at the markers on the right hand side. The markers tell me that I am on the line where M collided is, so it's flashing there. I've highlighted it on purpose so that I can see where it's used in these 3 other locations. It's used there, there, and there. So M collided, is it an M? It only ever happens in one function. If it happened in 2 functions, then it would be an M. It's not needed. You can do that. Then you do that. You just take the M off. And you just add it to your top. This is how you decide whether something is a member variable or not. Is it used externally from the function that's using it? If it is, then that's good. If it isn't, it's a bit bad. Counter. Where is that used? Can anybody tell me where it's used? No, because it isn't. We're not using it at all. Make sure I've got it highlighted. Go down. No highlighted. Nothing. It's not even being used. Okay, that's those 2 variables gone. Counter and M collided are not being used. So I can do that. Watch it come up with the errors now. Oh, Blades, what have you done? I've just removed all of those variables from here. The variables list got short. This is what you have to do. You have to go back to your code, or after you've finished the initial code, look through it. Look to see if there's any hacks. Hacks or if statements that only operate once. The hack was a hack because it singled out one segment for special treatment. That's a hack. Good programming treats all segments the same. And it looks, the actual code looks horrible because it'll have this if-else. And it'll only happen for one item once, and it'll happen for all items the rest of the times. So that it will never happen for that one item again in the entire life of the program. You'll have a line of code that will, or a section of code that will only ever operate once, ever. That's crazy. That's just absolutely crazy. Don't do it. Get a good design choice. Make the design of your programs good. Make your programming good. Make your bugs 0. We now have a game that will not bug out on you if you update the game logic to do extra things. Your game logic is now solid, good programming with no possible bugs because you have one segment that has special treatment that will not react how you think it will react if you decide to do jumps, climbing, swimming, underwater. Something will happen and that segment will suddenly do its own thing. And you'll never know why. And it'll be so unobvious why. Because when you initially, it might be 2 years down the line. It could be 6 months down the line. You can't remember that you programmed it like that and you had to put a hack in to get the movement right. No, it just doesn't happen like that. You can't program that way. there should be notes on every single file. There should be documentation on every single file. And the whole thing should have been developed using test development, by using testing and developing your code to work by test-driven development. I'm a big supporter of that, even though I didn't use it in this case because I knew that all the code had already previously been test and driven, and I knew that some of the code that I was going to put in was going to be wrong, which is, well, not wrong, but bad. And that's the point. That's the difference between good programming and bad programming. This programming will now work in all circumstances. It will be hard to break this program now. Let's see if taking those two variables out affected it, shall we? Nope. Doesn't affect it. Except for the fact that you got two variables less. I need to go in from the top side to make sure I've got to do that test. No, come on, I've got to get it in through the top. It's got to work in both directions. You can see it picking up properly. On that very first one, you can see it just picking it up. Oh. Can I crash into myself on the double? No. Have I fixed that problem, or is it? I'm just lucky, I think. Okay, that's looking good. I'm trying to crash into my tail here. Yeah, crashed into my tail just there. Fantastic, that works. That works perfectly. And that's your final program. That's the real game. But we did some error checking. It's been an hour of me doing this, and this is the first serious one that I've done. Most of the time I've been dead relaxed, and I've just said, yeah, this is how you program. Now I am saying this is how you program. Everybody should program. They should use test-driven development or some form of validation of code as the code is being generated. There should be full documentation on every single bit of code. Yes, every single bit of code should be documented. Everything that you do should first be designed. It should be designed well and correctly and without flippant ideas of, oh, let's make this private, we don't want anybody to touch it. Don't make things private unless you want to keep it private. There was no reason for Final Movement to be private, and there's no reason, but now we found there is a reason for it to be public, because it makes our game logic so much easier to write, and it actually makes our game logic correct. I'm done. I think that was I think that was hopefully driving home good programming over bugs and bad programming. There are no bugs. If you have bugs, you have a bad programmer. So I'm going to go and fire the programmer that did that hack, and then I'll probably have to re-recruit him to do some more videos for you, because his name's Blades. Thanks everyone. Thanks for putting up with that one. It means more to me than any other video I will probably ever do. I'm just glad I was able to give you it as a bonus video on the public domain. Take care. Program properly, program good, and have fun.